So what we're going to learn how to do today, guys, is we're going to have a re-look at how we can solve equations that contain square root symbols and the exponent of two symbols. What we discover is that if we have an equation containing square root, we can reverse that square root, Harry, by simply applying or raising everything in the equation to a power of 2. Or if we have an exponent of 2 in our equation, we can reverse that simply by square rooting an equation. So let's have a look at by example. If we have, for example, per se, what's your favorite variable, Posey?
I.
Let's not use I, but it is a good one. O? Okay, we'll go sigma. Sigma squared plus 3 equals, and we'll say it's going to be 28. What we're going to do is we're going to solve this equation here. Now, if we look at this, we've been used to solving equations of this nature. It's an unknown plus a variable equals some sort, unknown plus a constant equals some sort of constant value. The way we deal with this is we first start off and we say, let's treat sigma squared as if it is simply another variable. So let's rearrange to get sigma as the subject. To do this, our constant terms move to the right, our variable terms move to the left. We only have a variable term on our left, so we're happy with that. Our constant term needs to go. So I take it from both sides.
Can you move your camera so I can see you doing, please?
You might have to move your head for now. Sorry.
Can you move like the camera back?
Okay, next. We discover 28 take 3 is 25. And sigma squared equals 25. Or sorry, sigma squared equals 25. It's at this point we're up to trying to get rid of this square operation. Now we could think to ourselves, what two numbers multiplied together gives us 25? But there's a easier way to do this. We simply go, a squaring operation can be removed by using the square root on the expression. So I can simply say, square root both sides. This has the consequence of going sigma squared square rooted. 25 square rooted. And if we type in root 25 into our calculator, it's going to tell us that the square root of 25 is 5. The consequence of the squaring operation on a squared variable cancels out the square root and the square. So we discovered that sigma is 25. But there's a twist in the tail here. There's another. What happens if we put the square root of 25 in our calculator?
Do you want to check?
Put the square root of 25 in your calculator.
Okay, just for you. 5.
5. Okay, I want you to go 5 squared for me now. What do you get?
5 squared. Ooh, that's 25. 25.
Jamin?
Like 3.23.
I think there might be a mistake there. If you go square root of 25 is indeed 5, but if you go 5 squared, you're going to get square root of 25, which is 5. Now, here's the next part. I want you to go negative 5 squared. 25.
Why are you writing on an angle?
Just so I know to rub it out.
I got error line.
So I want you to put negative 5 and then square it in your calculator. Tell me what you get from here.
Negative 5 squared.
No, not the right-hand side of the board.
Negative 5 squared. Minus 25. Negative.
In brackets,
It's 5.
Still
negative
25.
5.
Yeah,
It's 5.
No, it's not. It's 25.
25. It's 5.
How come I got 25 on my calculator?
Right, so yeah, how did I get 25? I get macro.
I got Do you want to see my calculator?
900
and then
squared.
a square.
Oh my god. What was it? 5?
Harry,
25.
Harry,
That's negative, isn't it?
Harry, you've got to square root that.
I got it now.
I did.
Alright, what you discover is that, oops, don't need that. Okay, what you discover that is if you square a negative number and you square the positive counterpart of the number, you're going to get the same values. And then if you square root them, you get the same value as well. So what this implies is that whenever we apply the square root operation, we're actually expecting two possible solutions to what we could have. So we could discover that sigma equals 5 or sigma equals negative 5. It doesn't matter which one it is. If you put 5 back in this equation here, you're still going to get 25 coming out. So if I go 5 squared plus 3, it'll give us 28. If we go minus 5 squared, we'll get 25 plus the 3, we get 28. So there are two solutions, or two values for sigma, that will give us the solution we desire. Are there any questions? Okay. Next degree of complexity we could have. We could have, for example, the square root of, Conrad, give me a favorite number, don't even think about it. 36. Let's go 63. Oh, whoops. That's not what we want. Square root of x plus 6 equals 3. And we've got to do that the other way, sorry. Alright, Eisen's. We have the opposite situation on the board now. Not a good idea to come late and then start talking during the demonstration. Okay, we have root x plus 3 equals 6. How do we arrange for x here? Well, again, constants go on the right, variable terms go on the left. There's no variable terms on the right, so we're good there. Simply take 3 from both sides. This is going to give us 6, take 3, that's 3. Then we just have root x on the left. How do we reverse the square root symbol? What operation do we apply? Any ideas?
Power.
Yeah, we apply the power. We raise it to a power of 2. Depending on the root operation we're dealing with, your power might change, but for us in year 9 and for us in year 10, we're always going to do the power of 2. Okay, so
What do the dots mean?
ellipsis, it means something's in there. Okay, the squaring operation cancels out the square root operation. So we're going to get x equals 3 squared. 3 squared is 9. Now the question is, how many solutions are there to this one? 1 or 2?
2.
Just 1. The reason for this is that unless we apply a square rooting operation, we're only dealing with one possible solution here. So it's only 9. Are there any questions? Okay, so to summarize, what we've learnt in this is how we deal with operations of square root and powers of 2. To reverse the power of 2, you simply apply a square root. To reverse a square root, you simply apply a power of 2 to both sides of the equation. It should be the final thing you do whenever you're solving an equation. Are you clear? All right.